Awesome. So for the lab, basic file IO stuff, gonna take these files, cut, paste them where they need to be. Right in here. And we can do a good old fashioned IF stream file 1 equals IF stream colors 1, I think it is, dot text. Is it color? Oh, yes, colors, cool. Get all the basic includes in. There. And okay, so with this, just gonna use get. I need strings, don't I? Ugh. Why is that bad? Oh, one that's not a hashtag. Include IO string. There we go. Gonna do a good old fashioned string line, get line, file 1, line with a space delimiter, get line, file 1, line, no delimiter, cout, line, make sure this is a number. Run it and flick. Make sure this is a number. Yeah, so from that was just me stealing from the file. Color 1, it was this medium violet. I'll just skip in this, getting that number right there. So then using this, we talk about it in the lab doc. Using that integer, an integer stores 4 bytes. Those 4 bytes represent the 4 channels of color. RGB, now there's an alpha channel. We're ignoring the alpha channel, but it's still there. So right here, these are the 4 channels represented by 4 bytes. And so that integer just has these 4 bytes in there, built in. And so what we need to do is shift it the right number of bits. So we need to, so blue is in the right place already, but when we want green, we need to shift it 8. We want red, we need to shift it 16. Again, we don't need the alpha, but if we wanted the alpha component, we could shift it 24, yeah, 24. And then once we've got it in the far right position, so it's the color is represented by the first byte, because that's what we want. We want the first byte to represent it. So the first byte to be blue, green, red, or alpha channel. Then we do AND with 255. And 255 is a bunch of ones, and the AND operation does a bit by bit comparison. And anytime there's 2 ones, so if it's 1 and 0 or 0 and 1, it does 0, but anytime there's 2 ones, it replaces it with 1. So what that does is it makes it ignore all the other stuff. So in this case, it's a bunch of zeros, but if anything in this chunk of bits was 1, the result would have those be 0, because in 255, all of these are 0. Does that make sense? Yes. So if that doesn't make sense, I can go into more simpler details, but usually that is enough for some people. Okay. So yeah, if we had any 2 integer values and you ANDed them together, it would just go bit by bit, not byte by byte, but bit by bit. Remember, 1 byte is 8 bits. 1 bit can be either 0 or 1. It would go bit by bit and then result in something linear search. Not really a linear search, no, because it does it for all of them. There's no searching. It just goes one at a time. Okay, yes, it is a linear traversal. Sure, yes, that is correct. Yes. In my head, linear search, like it's not searching for one every time. It's just going one by one. But yes, linear traversal, just doing that. So with what we have here, what do we got? You're fine, you're fine. So with what we have here, first we need to get it to an integer. So let's get int color equals stoy line, sure. And then if we see out, well, let's get char blue equals, first, I'm gonna say int blue. Int blue equals color single and. So with Boolean operations, it'd be a double and, but bitwise operations, a single and. 255. So that would get us the blue component. To get the green component, that one was 1 byte off. So it's off by 1 byte. We need to shift them to the right. To do a bit shift to the right, does it say here? Yeah, so right here, it's this this less than symbol. I'm hoping it's less than symbol, not the greater than symbol. I think that's right. We'll see it when I try it out. It's either one or the other, and we're gonna get some colors. We're gonna try it. So that equals color. I think it's that. I'm gonna trust my gut and say it's that, but I could be wrong. And 55. So that's shifting it over 8 bits, which is 1 byte. And then name with 255. And then it red equals color, bit shift 16 and 255. And then if we see out, blue, space, green, space, red, and save that. Let's see what happens. 133, 21, 199. That sounds right. We can go to Zybooks, check some tests when it's the first one. The color we were looking at was the first in the file, so you have to sort it, but the first in the file was medium violet red. Medium violet red. 199, 21, 133. So I was right. Bit shifting right is that. So it shifts in the direction of the arrows. So these arrows are pointing right, not left. Yeah, that felt, I was like, I think I'm correct. Okay, so yeah, right bit shifts. Make sure you do do enough bits to shift a whole byte over, and then with 255 to isolate those first 8 bits, the first byte. Now, do we say anything about storing them in an unsigned char? Because it's stored in a byte, so you could store it in an unsigned char. I don't think we do. Yeah, I don't think we talk about that at all. So you can store it however you want. Yeah. So yeah, with this, you'll probably have to use, it's like a culmination of everything we talked about. You're probably gonna want to use a map to store each of the colors. You're probably gonna want to file IO maps, numeric conversion. So that's from like programming 1, that's a throwback. That's not going away. All the color stuff we've talked about. creating a color class is a great idea. Oh, so here's the color class unsigned. Okay, so we tell you that they have to be unsigned characters, so never mind. Since we say you have to make this, that means you have to make this. You have to have at least these things. Yeah, to be able to search it, some kind of, yeah, with a map object. Yeah. Okay, would it also work doing a shift color? No, that wouldn't work that way. It's not, what is that, community? Is it community? I think it's associative. One of the math things, but yeah, no, it doesn't work that way because it's saying take the left number and shift it how many bits what the right number is. So that'd be say take the number 8, which would be just 100. Yes, is that no 1000? Yeah, it would be saying take the number 1000, left shift it however large color is. So yeah, no, that would not work. Can you see that text by the way, or questions by the way, or am I talking to the boy? Okay, good. I realized there for a second that you might not. Okay. So that's really this lab. It's kind of a culmination of a lot of the stuff we talked about with the colors and the maps and the file IO, hexadecimal conversions, new for this class. We've done it before. You got to format your output properly. That's going to be a big one. Because look at this is all lined up neatly. So we are caring about formatting. So that was like lab 2 throwback all the way back to lab, I think it's 2, might be 1. Make sure you can take in different files because we only give you 1 and 2, but you should be able to load 1, 2, 3, 4, 5, or 6. I'd recommend having a string that you just append what you want. Just append the 1 to it. 1 through 6, don't just hard code that. You could, that one's not that bad though if you hard code the file names. Pretty colors, yes. Though when it outputs on Zybooks, you don't see the pretty colors. Okay, and then for this lab, a lot of these tests are hidden for you, I think. Yeah, I can see them, so I don't know what you see. But I think a lot of them are hidden. So if you get it working in most cases, but like one of the hidden ones isn't working for you, let me know. I can go look at it. And I've had some students who have weird interactions with like black or something where all the values are 0 or anything or 0. And so they're not printing out 0, 0, they just do 0. It's like down here. Can I get a black somewhere? It's like right here with dark blue, how the red component is 0 and the green component 0. They mess up with that and they just put 1, a singular 0. So some fuck up like that. If that happens, I will just send you the color that you're messing up. I'll just take from the file the like color you're messing up. And then you can run that. You can just add it to one of your files that you're testing with and check it out. Okay. Any questions on lab 8? Okay. So then with lab 8 done, all the rest of our time is going to be on project 3. I'm going to go over some sprite stuff, but hopefully by this point, I know we reviewed it real quick last time, but hopefully you guys have thoroughly read it and played some Minesweeper now, so you can have some questions. Yeah, the lab is very straightforward. The lab hopefully is very easy. It's just a culmination of a lot of stuff we've done, so it's hard in that aspect. But hopefully this week you have plenty of time to focus on the project because next week you guys have the project due and the quiz and the lab due. Yeah, the project is due on the 21st. Quiz is due on the 20th. Lab is due on the 18th. So there's a lot next week. Okay, yeah, Gabby, if you haven't played Minesweeper, you're gonna be at a disadvantage. At this point, you should know how to play Minesweeper. It's 2 weeks from now, but so that's why I'm saying like you should start working on it now so that next week when you have the lab project and quiz, you're not as stressed. Yes. I would say last week was the week to relax, even though you did have a lab and a quiz in the project. The project wasn't due for a while, so it was just a lab and the quiz. This week is the week to like try to pump out a lot of it. Okay, so yeah, with the project, hopefully you've read through it and know how to play Minesweeper so you can ask some questions about stuff. If we have the milestone done by next week, will we be on track? Yes. I definitely say more is better, but theoretically, the milestones are just there to make sure that you're working, because we have some students who come in like the Saturday before and like, I haven't started, and they're basically fucked, which is fine, but we try to not encourage that. So I've seen people do this project in a day and still pass it, but it's not good for your mental health. It's not good for your other classes. It's not good in general. So yeah, okay. So yes, here, I'm gonna go over drawing some sprites and hopefully you guys have some questions. But for sprite drawing, just SFML sprite, Google that. First link that pops up, I think is good. Second link. What is this first link? Let me take a look at it real quick, but I think the second link is what I want. Yeah, okay, so this first link that pops up is more documentation, not really a tutorial. The second link is what I want. Yeah, okay, so this is the link that's really nice. So I'm gonna have that. And then also for the project, let me copy over. Starting from the green circle is a great idea. So I'm gonna go grab that again, learn, tutorials, Visual Studio, green circle. I would say an hour is pretty bad too, Gabby, but you know, live your best life. Okay, so here's SML graphics. Yeah, starting from this is a great idea. Just using this as a baseline, because you're gonna want this while loop with the while windows open, and you're gonna want this event loop. So make sure that you keep this from the green circle, don't get rid of it. And also this clear draw display component. Definitely better than usual, better than 10 minutes. So this clear draw display loop, you're gonna want all of your draws to go between this clear and display, and so you're gonna wanna keep those there. Don't fuck with the clear and display, because the way graphics works is that you erase everything that's there, draw a bunch of times, and it keeps just overwriting what's there. So if you draw one pixel over another, it just covers it and it's gone now. But other pixels that weren't over, like other pixels that just exist in the space, stay there. So you're filling the image with all these draws. And then when you finally display, that's when it graphically like actually displays all the pixels you've done. So it just kind of internally stores the pixels. If you've ever tried to print out a lot of information, it was really slow, it's to avoid that kind of thing. You don't want it to continuously add stuff to a window, because that would take a really long time. It just adds it internally, and then finally when you call the display function, it draws it, and then clear resets everything. So this is the loop. This is what you want to have. You don't want to try to start from scratch. So yeah, you want all these basic components. I think the difference is like this. You want to change it to Minesweeper. The width and height of the window, you want it based off of the file we load in, the config file. We're not drawing a circle, so I'm going to get rid of the circle. I'm going to get rid of this. But yeah, everything here you're going to want to keep, I guess, except changing these things. But I'm going to leave them for now. So with this, I'm going to open up my root directory here, and I'm going to throw in from Minesweeper. That's not what I want. This, there we go. From here into the Visual Studio folder, I'm going to move the board and images. So setup very similar to project 2, just keep it that way. You're not making a make file for this, but you do need to make sure that these are there, because when I run your project, I'll basically just be placing the source code into my SFML project, and so that's where those will be. So use it like this. So yeah, from there, what images do we have? I'm gonna steal debug, sure. So we're just gonna go over drawing a basic debug, just a basic sprite using this and the tutorial here. So first off, we want to load in a texture. Fox has a great video covering a texture map. You're probably going to want to do that because you should make a tile object, but you don't want each tile object to have a texture, or else your thing will take up a billion bytes of code, like gigabytes of code. No. If you tell me beforehand, like I would not do it at all unless you explicitly tell me beforehand and I give you the okay, because it can fuck up how I grade it. Because I'm going to be grading a lot of these and I'm going to be expecting it to look one way. If it doesn't, it will fuck up how I grade. So do not make your own textures unless you get the okay from me first explicitly for each texture that you want to replace. And actually, because just like you'd have to submit it with your project and I'd have to like replace it with my thing if you wanted to make it look special. Yeah, no, don't do that. Okay, so in here, we love it when the lights go out. It's gonna throw in this, and I'm gonna say images/debug. That's what it was called, right? Debug, yeah, perfect. And I'm just gonna put a little cout statement. Don't need to do this part. I'm just gonna follow along with the tutorial. That's why I'm putting it. Add a little, include stream using name space. There we go. There we go. Okay, so loading in the texture, awesome. Loading, and we don't need to load in a small, you might need to do this for the digits so you can mess around with that, but we're just going to talk about the debug button. You're never going to be creating an empty texture. That's not going to happen. You never need to update a texture. You won't need to set anything about the texture. Don't need to set anything about that. Yeah, so you just need to load it in. You might want to specifically load in a certain part of it. That one, like I said, you'll need for the digits, but we can go over that later. So here with the sprite, now I'm gonna make a sprite object. And then set the texture to be the texture that I have. I just could have copied it right from here, but I recommend for you guys to type it out as you go just to get more muscle memory. It's like writing practice in kindergarten. And then now down here, window.draw sprite. Hopefully it figures itself. I'm just going to compile it. And with that, we should see a little debug button. Maybe. Oh. Did it print anything out in the console? Failed to load images/debug.png. Okay. Okay. Did I? Oh, I do see the debug. That's a valid point. I still spelled it wrong. Don't at me. Debug. There we go. There it goes. Now we got a big old debug button there. So the next thing, let's not do the debug button. That's kind of large. Let's do, I think it's like hidden. Yeah, tile hidden. I'm just going to copy and paste it from here. Yes. like I said, the if not thing, you don't need to do that every single time. That's just because I'm following this tutorial. But yes, you would need to load it in from each individually. You need to load them in. So there we go. We got a tile hidden. Now to change where that's drawn, let's put a little for loop in here. Let's do for int I equals 0. Let's do 4 of them. I is less than 4 plus plus I. And then sprite dot set low position. There we go. Let's say 0 I comma 0. So it's gonna just 4 in a row. And actually, let's just double for loop this, nested for loop this for shits and giggles. For and j equals 0, j is less than 4, plus plus j, same thing. And then I comma j. So if we draw this, it's gonna look a little wonky. It's not gonna be what you might expect. So right here, this looks like just one giant, it just looks like one tile, but I drew 4 of them, so what the hell happened? Well, if we take this and we increase the size, you'll notice that it's not actually a normal tile. There's a little extra stuff on the left and above. That's because it did actually draw 4 tiles. It just drew them on top of each other. The reason why I drew them on top of each other is because when I did set position I comma j, that is relative to pixels. So position is relative to pixels. It does not know that we're trying to draw tiles. SFML is a very generic thing. It lives its best life. It does everything relative to pixels. And so in order to actually draw them so they look adjacent to our eyes, we need to know how big they are pixels-wise, the height and width. Spoiler alert, it's 32 pixels. I think it talks about that somewhere in the document. But if we do times 32, in times 32, chat. But if it's PNG file, isn't it made of vector? What? Are PNG files made of vector? But it, what? I don't, well, whatever they're stored as, it doesn't matter. It's loading them in as textures. And so now stored as textures, it's all pixels. And I couldn't have told you that PNG files are stored as vectors, sure. Yes, textures are a thing for SFML, and so it could load more than just PNG files, but it converts it all to pixels, yeah. So here, we draw it. Now it looks like what we wanted. So relative to pixels, it drew them 32, and it's also relative to that top left corner. Oh, okay, let's just maximize it. It scales itself as you scale the window, so they're not square right now, but that's just because it scaled the pixels. But yeah, it's relative. So first off, the sprites are relative to the top left corner. So 0, 0 is the top left, not the bottom left. So make sure you know that. And then also it drew them 32 pixels apart. Yeah, I think PNG stands for pixelated something something. PNG files are portable network graphics. Sure. Oh, it uses lossless compression. That's what it is. It doesn't lose anything. So it's still, it might be stored as vectors. It might be stored as vectors, but it's like, it uses vectors to compress the data. That's all it is. Okay, so now it looks like what we wanted. Cool. The next thing that I want to show off here is how to register what tile you click on. So the way we get clicks, so we've covered everything in here. Now that I've shown that, theoretically, you could just draw a board. It would be static, no interaction can be done, but you should be able to draw all the hidden tiles, all the smiley faces, all the debug buttons. I guess, oh, the numbers. I'm gonna leave the numbers to you guys to figure out. That's you can like try this, mess around with this yourself. If you have issues, obviously offsiders exist. If you've tried something, it doesn't work, but I'm gonna leave you guys that to mess around with yourself. Okay. So yeah, next, to handle events. So SFML mouse click event, sure. That's not what I want. So just events tutorial. Keyboard, mouse. I thought, but where's the events? Does this do events with combination? There. Yeah, this is what we want. So I'm just going to copy and paste literally this into the event handler, which is right here. There. Yeah, there we go. So run this. So if I click anywhere, oh, and it has to be the right click. Did it? So yeah, it's specifically right clicking. You could make it left by just replacing this with left, sure. But so yeah, right clicking inside things. And so again, you'll notice the mouse X and Y position relative to pixels. It will not be 0, 0 anywhere you click here. It's relative to pixels. But hopefully you might be able to think of a way to turn any, so even if we go all the way to as close to the bottom right corner as we can, it'll never go greater than 32, 32. So hopefully you guys know a way to convert a number that's less than 32 down to 0, or a number that's like by relative to 32. There is a very easy operation to do that with. What am I trying to say there? Oh yeah. Yeah, yes, there's a very easy operation to go from the XY coordinate to what tile you click. And it has something to do with the fact that these are integers. So I'll leave it to you guys. But for mouse clicking, just in general, so right here, this thing right here, this is mouse. If the event is mouse button pressed, it'll print something here. The only thing you got to keep out for is that if I hold down right click, oh, it's no. So which one is hold down as fuck? So this is pressed is fine. Mouse button event. Is it pressed? There's one that's annoying. This seems fine though. Well, okay, I'll say it now just in case it comes up later. If you ever run into an issue where holding down the button fucks with stuff, so sometimes some students, when they have the Minesweeper reveal stuff, so like right clicking is supposed to place a flag. Well, sometimes they have it where it right clicks multiple times with a single right click, and that can really fuck up your ability to place because it's basically random whether or not a flag gets placed. And so a way to get around that is instead of doing pressed, I found telling students to do released. And so now it happens on release. You know, saying pressed, just because I didn't change the C out statement. So that's how you get the mouse click. And so using that and the coordinate, you should be able to tell which tile was clicked. And then using that information, hopefully you have a vector of tiles and then tile objects, and then you go to the right tile and the tile object and change the texture on the sprite. And so theoretically you have a vector of tiles, you draw all of them every single frame. They might have some conditions like is revealed, is mine, and stuff like that. And every time you draw it, you use that information to be like, do I need to draw a hidden tile? Do I need to draw a revealed tile? Do I need to draw mine? Do I need to draw a number? That kind of thing. And so when you click on it, that affects it. Like with right click, there'd be a flag. So maybe bool is like has flag. And so when you draw it, you draw a hidden tile and then a flag because it has that true revealed thing. So think about functions that you could do. So you probably have a tile class as a function that goes through all the bools to see what it needs to draw every single frame. And so then you just have to do whatever your tile object dot draw function. One thing to note is that you can pass this window object into a function, if you just pass it by reference. So in a function, you can have a render window as a parameter. So we can have SF render, render window, reference window, and then SF sprite. So you can have something like this and then do window dot draw sprite. And so with this, we could replace this right here with draw sprite, window sprite. I probably should have passed the sprite by reference too, but we'll live. But stuff like that. So that's how you can make things functions and not have to do all of that in main constantly, because you can pass window by reference. That's one that usually tricks up people too. They're like, how do I draw inside a function when I need that window object? So yeah, got mouse events. Left versus right mouse event would just be right here. I recommend release, but it looks like pressed was working. Just make sure you don't have something that causes it to repeatedly with just a single click multiple times. Okay, so yeah, make sure you know how to play Minesweeper. Oh, reading in the config file. This isn't supposed to be a super hard part just to help the TAs, but it is still worth some points. So you read in the con file, see the width and height of mines. And so right here, we give you the calculations. So for the width of your window, it should be the number of columns times 32, because the number of columns is the number of tiles there. The height should be the number of rows times 32 plus 88. The 88 comes from the space for the menu. So that's the, when we see this right here, that 88 gives you extra space there. It's not, there is definitely still some blank space down there, but that's just the amount of room we want you to use. Tile count, have a variable for tile count, don't hard code it. All your image files, click millions, adjacent mine. So you should be each tile should probably have like a vector of tile pointers to all their adjacent tiles. And that should just happen at initial setup. So you shouldn't do that every frame of the game. Just upon initial setup before you get into your main loop of the game, set up your game object, and in doing that, set up your tiles. And that would make it so they figure out all their adjacent ones. That's just going to be a lot of if statements to check to see if it's a corner or not. It does just take a bit of code to do this. Reading the config file, loading from the test files, it's just a bunch of ones and zeros. Text file though, so it's not binary, but it's still a bunch of ones and zeros. Ones representing mines, 0 representing empty spaces. And the config file will match the test file. So if we change the test file, if we change the test files, we'll change the config file. So you don't have to worry about that. File paths. So yeah, so I told you to talk about that somewhere in there. So just make sure that you can do this with it. Don't use backslashes, use a single forward. Oh, wait, use double backslash, don't use single forward. Yeah. Talked about tiles, storing resources. So like I said, I'm fairly certain Fox has a video on the texture map. So for texture specifically, you can have sprite objects. Sprite objects are fine. So each tile can have a sprite object or however many you want, but don't have each tile object have its own texture. Create a map of textures. Read through the SFML documentation. I covered a little bit. I tried to go as close to the documentation as possible as explaining it, but do that yourself as well. Some tips. Yeah. Some other things that I know I've seen for random mine placement. Don't go through your vector from the beginning and like do a check to see if like do a random number generator to see if it's a mine, and like basically if you do it that way, one, you might not always do so, like unless you go over it multiple times. So if your randomness is low enough, you could do it and then just make sure, so then it would go over all the mines multiple times until it placed the right number of mines. I could see that, but that's still just a bad way in general. What you should do is pick a random number between the width, between the random number between 0 and the width, and a random number between 0 and the height, and place a mine there and do that 50 times. And if you ever get a repeat, just do another one. So don't count that. So that's the way you should do random mines. With that method though, make sure that you don't ignore the bottom edge or the right edge. I've seen that happen before. I'll take off points for that. It needs to be random across the whole board. I'll just reset the board multiple times. Trying to think of anything else. Everyone's project for this is unique. So there can be a bunch of different errors. Like I said, it's very hard to get 100% on this one. There's a lot of little things that can go wrong. Okay. Any questions on all that? We covered a lot in a short bit of time. Okay, with that, I am done with my spiel for today. If you guys want to stick around, work on your project, and if you have any questions, I'm here to answer it. I'm here for you guys for the next technically hour, but I'd prefer 45 minutes so I can get to my next class on time. But yeah, I'm done with talking unless you guys have questions. Stop recording.